Hey, everybody. Welcome to our third apportionment lesson for social justice math. This one's going to focus a lot on methods that different individuals have used to actually gerrymander certain areas and some mathematical measurements that we can use to help us recognize when things might be gerrymandered and when they might not be. So to start out a bit, let's go over some historical perspectives on this. So we mentioned this before in a previous lesson, but we had the court case Shaw versus Reno in 1993. And these things could be an entire course on their own, the history of gerrymandering and especially how it's done in the legal sphere and what the responses to it have been through the Supreme Court and things like that. So I'm going to give a very, very extremely brief, scratch the surface kind of history lesson here. So in Shaw versus Reno, the Supreme Court affirmed that race may be considered when drawing these lines for districts. They say the legislator is always aware of race when it draws district lines, just as it's aware of age, economic status, religious, and political persuasion. That sort of race consciousness does not lead inevitably to impermissible race discrimination and may reflect wholly legitimate purposes. They did in this provide some guidelines to help us understand how these lines should be drawn, though. He said the district lines may be drawn, for example, to provide compact districts of contiguous territory or to maintain the integrity of political subdivisions. So a couple of these are highlighted here. We have compact, we have contiguous, and we have political subdivisions. Contiguous just means it's one piece. Obviously, we would understand what political subdivisions mean, talking about different groups of voters who are likely to vote alike. Compact is going to be the big thing we're going to explore here, especially from a mathematical perspective. So in 1997, they double down on this and say that it's okay to preserve communities of interest. And those can be neighborhoods, they can be urban areas, they can be rural areas, industrial areas, counties, towns, anything like that. And that is fine to preserve when you're drawing the maps for this apportionment. Now, the Voting Rights Act says that you cannot deny or bridge a person's right to vote based on their race or membership in a language minority group. And there have been a couple different things to happen here. So in our very own city, Mobile, City of Mobile versus Bolden said that some of the districts drawn had a discriminatory effect, but were adopted without discriminatory intent. And another one, Thornburg versus Gingles, actually set forth some guidelines that people need to use in order to prove whether something has been gerrymandered or not. So if you're challenging a district, the things you need to prove are that the minority in your district is large and compact enough to constitute a majority in a single member district. You need to prove that it's politically cohesive, meaning they tend to vote together. And you need to prove that in the absence of special circumstances, so in general, block voting by the white majority would usually defeat the minority's preferred candidate. So you need to say the minority is large enough to constitute their own district. They tend to vote the same way, and their voting interests are usually suppressed by a white majority in another district. Right. So in another section of the Voting Rights Act, there are actually covered jurisdictions that have to have their plans for apportionment and the redrawing of districts pre-cleared. So before they even get approved, they have to go through a review process where a third party will take a look at them and make sure that they're okay. Now, most of this was in southern regions with a history of racial discrimination, especially after the Civil War and things like that. And so some districts, or rather some areas, were entire states that had to have their districts looked at. Others were specific cities or counties that needed to be looked at. But the way it worked was as long as the redistricting left the racial minorities and language minorities no worse off than they were before, then pre-clearance was granted, which I'll leave you to decide how you feel about that phrase there. But that was how it was legally done. Now, in 2013, the Supreme Court actually vacated the list of covered jurisdictions, meaning they took everything on the list and just got rid of it. So the list still exists. This Section 5 of the Voting Rights Act still exists, but there's no counties, no states, no areas on it that need to be pre-cleared. So the mechanisms are there if it comes back in the future, but currently there is nothing that needs to be pre-cleared. Okay, so let's get into how gerrymandering works from a practical perspective. How would somebody draw these districts in order to make them quote unquote gerrymandered? How would they do it to make these districts to their advantage? And there's two main mechanisms that come with this. One is called packing, in which you take all of the voters that you want that support you and you put them all in a single district, right, to minimize their seat output. So in this case, right, let's say I am running with party A and there's a bunch of different voters for party B, and I know they're going to vote against me. So what I can do is I can take all of them, right, everybody who votes for party A, and just stick them in one district. And I'm definitely going to lose that district, but they won't affect any of the other districts. So if I have 5 districts total and I manage to cram all of them into one, then I know I'm going to lose one, but I'm going to get 4 to my party. So that is how packing works, right? We're going to take everybody who's going to vote against us and we're just going to stick them in one district. We're going to say, we're going to write that district off. That's a loss for us, but we're going to win everything else. Now, the other thing you can do is kind of the reverse of this. It's called cracking. And what you can do is take a very geographically centered area, right? So a small geographic area, something like a city, and you can break it into multiple pieces. And what that does is it dilutes the voting power. So if you have a lot of voters that are not going to vote for your party in a small area, you can break up that small area into multiple districts. And then what happens is together as a whole, they may be able to win something, but when broken up into pieces, they get outvoted. All right. So these are the two main mechanisms here that we have for our gerrymandering. And you can actually see these in action. So here's Utah, right? You can see there are 4 districts in Utah, and they don't look terrible to begin with, right? There's clearly some natural boundaries here, right? Some natural boundaries here. You can kind of see them broken up by county as well. But one thing you'll notice is that Salt Lake City is right here at this central area where all of these districts, 1, 2, 3, and 4, all kind of meet. Now in Utah, Salt Lake City happens to be a fairly progressive voting population as compared to the rest of the state. So what is happening here is that Utah, and specifically Salt Lake City, is being cracked into 4 different pieces to dilute the voting power of the people in Salt Lake City. So all the people in these rural areas, right, which may outnumber a small piece of Salt Lake City, but Salt Lake City is obviously going to have a very large population, right? When it's broken up, these rural areas are going to outvote these parts of Salt Lake City. So this is an example of cracking in this case. And you can look at a similar map in Austin, Texas, which is also fairly progressive compared to the rest of the area, and especially Texas in general. And that is split into 6 entire districts. Just in Austin itself, it's broken up into 6 districts. All right, so let's talk about packing. This is Illinois. This is an actual district. It is wild. So this is the 4th district of Illinois, and it wraps around Chicago. So Chicago's here in the middle. So it goes all the way around and gets the top and the bottom here. So jokingly, this is called the earmuffs district because if you have quite the imagination or your eyes are very blurry, you can imagine this being some earmuffs turned to the side. Now, this was actually found not to violate the Equal Protection Clause, right? The district itself was drawn to allow for representation of 2 large Hispanic populations that are to the north and to the south of Chicago. So, of course, these areas have to be one piece, right? We can't have this piece up here and this piece up here, and they're not connected. So we had to have some way to connect them. So in this case, they are linked by this area here. And so this allows the representation of these 2 Hispanic groups. Now, if one of these populations, either to the north or the south, were to grow to the size that they might support their own district, right, without being connected like this, then this could be ruled illegal racial gerrymandering because you would have one population that could support its own district. All right, so let's do a little bit of practice here, right? Let's say, again, very simple. We have this rectangular state and we have 30 people or 30 blocks of people that tend to vote along party lines. So we have a green party, right? And we have a purple party here. So if we look, right, a couple questions to ask just to get us some information, right? What proportion of the population is in the purple party and what part is in the green party? So we have 30 blocks total. So it looks like 3, 4, so 7 total, and then 5, so 12 are in the purple party. So that would be 40% are in the purple party. That would leave the leftover 60% being in the green party. So if we were to break this into 6 districts, how many population blocks should be included in each district? Well, each one has to have the same amount of people, right? It has to have the same amount of population. So we have 30 total blocks. We need to break them into 6 districts. So that means I should have 5 blocks in each of these districts. So we have to have 5 in each one, and they have to connect up with each other. I can't have these 3 over here and then these 2 over here and not connect them up, right? So those are kind of our basic rules when it comes to making these districts. So question, if we want to maximize the effect of our purple vote, right? If we want the purple party to be as efficient as possible, how many purple blocks should go into each district? So let's think about this for a second. We have 5 total blocks in each district, right? So in order to get a majority, 3 of them would have to vote the same way. Now the other 2 can be whatever they want. And we have 3, 7, 12, right? Different purple blocks. So the idea here would be, well, if we have 5 blocks, I would need 3 of them to be purple in order to get that district to go purple. I have 12 total purple blocks. And so ideally, I would like to break them into groups of 3 and have 4 different groups of 3. So maybe these 3, these 3, these 3, and these 3, right? That's just an example, right? So if we can do that, and we can break it up in such a way that obeys our rules, so every district is 5 people, every district, right, is one solid piece, right? It can be really thin, it can be stretched out, it can be these 5 here in the corner if we want, but everything's one piece and everything has 5 blocks, right? Is there a way that we can use packing and cracking to break up the green party so that purple wins 4 of the 6 districts? So even though they're only 40% of the total population, can we get them to win 4 districts? Right, so I'm going to let y'all work on that, right? Go ahead and pause the video here and try and do that. We'll see the answer in a little bit. Comes on a little later in the slides. Okay, so let's talk about compactness. That was that measurement in Shaw versus Reno, right? That is mentioned along with contiguity. So everything has to be one piece. Cool. Compactness, though, that's an entirely different term. Now, there's a lot of mathematical definitions for this. In fact, there are 36 different ones just that have appeared in court cases. So a lot of different ways we can look at compactness in this sense. Now, the 2 most popular ones are what we call the Rioch score, right? So that is just looking at the fraction of the district's area and the area of the smallest circle containing the district, and the Polsby-Popper score. And this is the one we're actually going to focus on the most here. So this is going to be a way we're going to measure whether or not a district is compact or not. And the way we do that is something called isoperimetry. So isoperimetry just means perimeters of equal length, and it's a way to study how different perimeters can enclose different areas. So if you have the same perimeter for a square as you do for a rectangle, as you do for a triangle, as you do for a circle, each one of those is going to enclose a slightly different area, even though it is the same perimeter. So you can imagine having some fence that you need to set out, and depending on what shape you put the fence in, determines how much land the fence is enclosing. Now, the cool thing is that we can say with isoperimetry that any 2-dimensional shape, right, is going to obey this inequality right here. So if I look at the area of the shape, that's the capital A, and the perimeter, right, and that's the capital P here, I know that this fraction is going to be between 0 and 1 over 4 pi. And the only way it gets to 1 over 4 pi is if the shape is a circle, right? So we can use this inequality to our advantage, right? We can take this and we can use it to figure out how compact a district is. So what we want is we want to score from 0 to 100. 0 being it's not compact at all, right? It's very like wiry and spread out. Think the earmuffs district, or if you go back to the last lesson, think about the North Carolina 12th district, right? Something that's really spread out, not very grouped together at all. And then 100 would be totally compact. That would represent an actual circle, right? Where this is our district. It's just a circle, as compact as we can get, as close together as we can get everything. And so with a little bit of math, we can take this that goes from 0 to 4 pi, right? Multiply everything by 4 pi, and then multiply everything by 100. So just a little bit of algebra here. And what we end up with is this. So on one side, we have 0, which would be not compact. On the other side, we have 100, which would be totally compact. And this is our thing in the middle. This is going to be our formula. So the Polsby-Popper compactness score of a district is 400 times pi times the area all over the perimeter squared. So this is the formula we're interested in. And this is going to give us a number between 0 and 100. If it gives you something else, you done goobered, right? It's got to be between 0 and 100. Now, it could be 100. It'll never be 0, but it could be close to 0. So we can look at this and we can figure out how compact a district is. So here's our example from earlier, and we've actually split it up in such a way that the purple party has 4 votes. So you can see this district here, this red one will go purple. This blue one will go purple. This one over here that's kind of gray will go purple. And then this orange one will go purple. And then we've packed in this district down here, this yellow one, and then this dark purple up here in the corner. We've packed that in as well with green members. So we've split up some green. We've done some cracking here. We took this green area right here and split it up. We've also done some packing, putting them into the same districts to ensure that purple has 4 of the 6 seats here. So what we can do in this scenario is we can count up the perimeter and the area and then use our formula to figure out how compact each district is, right? So let's do one as an example. Let's figure out how we would do this, and then I'll leave the rest to you. Of course, I'll do an example of this on our Canvas page as well. So if you'd like to see that, you can check it out there. But what we're going to do, let's take this red district here in the top left corner, right? Our area is going to be 5 because we have 5 blocks inside, and that's going to be true for everything in here. All of our districts in here are going to have 5 because they have to have 5. That's how we split them up. That was our rule from earlier. So our area is always going to be 5 in this example. However, the perimeter is going to change. So let's start at this top left corner. So I'm going to go 1, 2, 3 across, 4, 5, 6, 7, 8, 9, 10. And I'm back to where I started. So in this case, the perimeter of this district is 10. So I'd plug that in here and get 10 squared. And so I would evaluate this out. 400 times pi times 5 divided by 10 squared. And that would give me my compactness score for that district. And then I would do the same thing for these other districts. So we can see this one actually has the same shape here, right? So I'd go 3, 5, 7, 8, 9, 10. I'd still get 10. I still have an area of 5. So that one would actually get the same compactness score. If we go here to this blue one in the bottom left corner, start at the top left, we'll go 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, so that 12 would go down there for the perimeter for this one. So we're going to end up with 6 different scores, one for each of the districts. So I want you to try and calculate those out and then rank them by compactness. Remember, the closer it is to 0, the worse it is. The closer it is to 100, the better it is, at least as far as compactness goes. So with that, you have your worksheet on Canvas if you're in my social justice math class. So make sure you go ahead and finish that up by whatever the due date is, depending on when you're watching this. And if you want to look at this as far as the resource for redrawing these districts and how they would stand up in court and some guidelines for that, the Minnesota Senate Council has a link here that you can follow if you'd prefer to do that and investigate a little more, because there is a lot to look at here. So with that being said, thank you for your time. Thanks for watching, and I'll see you in the next one.